Complex numbers now takes us away from the real numbers. First off, let's talk about what real numbers are. Remember, we always say all real numbers are from negative infinity to positive infinity. Those are all real numbers. But what are they? How do we build them up? In academia, in elementary school, what's the first type of numbers you learn? Yeah. No, not before that. You first learn natural numbers. Natural numbers are also called the counting numbers. If you're playing in the playground and you're playing hide and go seek and you're giving them 10 seconds, how would you count? 1, 2, 3, 4, and so on and so forth. You start off at 1. Because you don't start with a concept that's very difficult. It's easy to teach kids about number 1. I have one pen, one marker. I have one pen. You can associate that. And then you go to 2, 3, 4. Even in the development of algebra, the most difficult concept they came up with at the time was this next one. The natural numbers, we use that symbol. Whole numbers, we use that symbol. The whole numbers begin with a whole. 0, 1, 2, 3, and so to infinity. Why do we not start off with 0? How do you define 0? It took hundreds of years for people to develop, when they developed algebra, it took them hundreds of years once they got that far to develop the number 0. Because how do you talk about nothing? But you have to have it for equality purposes. If I had 4 cows and you had 10 sheep, is that a good deal? Well, we'd agree on something, and then if it's equal, then I owe you nothing else. But if you had 4 cows and I only had 3 sheep, I owe you money, some other stuff. So 0 was a way to define equality in business. So now, once we finish that, we now look at integers. Integers start off at negative infinity, go through the negatives, 0, and all the positives. Integers are the numbers. Oh, is that imaginary? Hold off on this one. I think it may just define imaginary. I have to think of that one. So, because once we talk about positive numbers, we introduce 0. It's on the other side. If we go forward, we're positive. We go backwards, we're negative. That's okay. But then, how many numbers are there between 0 and 1? Infinite many numbers. Infinite many. You have 0.1, 0.2, all the way to 0.9. Even between 0.1 and 0.2, you have 0.1111 or 0.1999999. So you have an infinite number of numbers between them. We call those rational numbers. Or, as we call them, fractions. But more importantly, rational numbers are called quotient numbers. Those are the decimals. And its symbol is that. So a rational number is any number that can be written as a fraction. That's a rational number. Okay, now what's a rational number? Any number that has finite number of decimals, like 1.25, or continuously repeating decimals. One 1.5555 forever. And if that's the case, then we would simply write our number with a bar over it. If it's in a sequence of 2 digits, then we would write 2.35 with a bar over that. So the bar over a number means from that point on, that's repeating. Those are rational numbers. Are all numbers rational? 5, is it rational? 5 is the same thing as 5.0. Yes, because it's a finite number of decimals. But not all numbers are rational. We also have irrational numbers. Irrational numbers are defined like this. Any number that is not rational. That took a lot of thought to define. Irrational means it's not rational. Duh. Give me some examples. Pi. E. These are constants used in mathematics. So far, so good. What's that? E is what's called the natural number. What it does, it's 2.718175. It's just it's some number. It's brought about by that as n goes to infinity. If you add up all the numbers, but it's a whole number. So, but for this course, we will spend a lot of time. We will spend a lot of time in chapter 5 talking about E.
Is there more of a capitalism?
Not really. It's more of a. It's more. It's used in the reason I call it a natural number is because it's used mostly in biology or anything to deal with living organisms. Like, for example, when we had the pandemic, when the COVID first started, few people had it. Then it went up higher, and then it went like this. Because anytime there's a curve that increasing, it grows faster than normal. Well, here you have one person got one person sick. Now you have 2 people sick. They go to the hospital. How many people do they get? Those 2 people now got the doctors and the nurses sick. Now you have 20. Those doctors and nurses got those people, those patients. So it grows exponentially. That's what that is. That's an exponential number. And that's what happens here. Eventually, everybody's so sick that nobody else can get sick, which is, I don't know if you guys know what Ebola is. Ebola was one of the first scares that almost destroyed the world. It started in Africa. Uh, some scientists went into a cave, and inside caves, bats live, and all this bat guano, the poop, is on these rocks. Well, one of these researchers cut themselves on these rocks with this bat crap on it, and they got infected. This is the story that they said. And so they went to the hospital. All of a sudden, the one person got really, really sick. And what happened? Well, I won't get too gory, but pretty much your insides become liquid and come outside. So they went to the hospital and got the doctors and nurses sick. And then those doctors and nurses didn't know what it was, so they just put them aside and went treating other people. Well, they touched everybody and coughed on them and this. So, and all these people, then some of these tourists who were in the hospital, they got sick. They went on the airplane. They went back home. Now everybody in the airplane got sick, and they spread. So you see, and this is we have no cure for Ebola. We still don't have a cure for Ebola. But all of a sudden it started, and at the very end it stopped without anybody knowing why. We got lucky. The world could have been eliminated at that point. Because think of how many people travel everywhere. They go to the hospital. Now you have all these millions of people in the airport. I mean, they get infected. They go to the airport. So we got very close with that. Anyway, back to this. So we have real numbers. All of these numbers define real numbers. But there are other numbers. Real numbers are numbers we can calculate, we can grasp, we can graph. If they're not real, those are called imaginary numbers. Imaginary numbers are numbers that we cannot graph. For example, can you solve this? No, because no two numbers multiplied together will give you a negative number. This is where it came up, and that's why we call it imaginary. We can't graph it, we can't really understand it. It came up in engineering. It happens that sometimes you will come up with something with a negative side there, and instead of just quitting and stopping, let's just give it a value and keep on going. So that these two, we have imaginary numbers in this. This brings up a whole new realm of numbers called complex numbers. Complex numbers is defined with that letter. Complex numbers are real numbers and imaginary numbers. And this is the way we write it. Every number is a complex number. Is that a complex number? Yeah, because we have a real number and we have an imaginary number. Is that a complex number? Yes, it is. because the real part's 0. Is that a complex number? Yes, it is. Because 0 is a real number. It's an integer we can use in there. That makes sense now? So now let's look at the realm of imaginary numbers. So as I said, the square root of -1 is equal to I. We can go one step further. How do we get rid of the square root? What do we have to do? If we do what? If we square both sides. So the square root and the square cancel. So now we have this other formula. So I itself is the same thing as square root of -1. I squared is -1. So rewrite this number. Rewrite that number. Well, what this number is really like, because remember you have a negative inside there, it's the same thing as -1 times 7. Because it's a product, I can split these up. Because radicals can be separated like this. So, what is the square root of -1? I. So the answer is I radical 7. How about the square root of -16? What's that one going to be? Basically, here's the rule. If you have a negative inside of square root, just put an I in front of it and drop that negative. So this negative comes out, it becomes an I. So what's the square root of 16? So the answer is 4I. Negative of radical -13. What's that one going to be? Remember, the negative's inside there, inside the square root, it comes out as a what? As an I. The negative stays there. It does nothing changes it. There's no reason to change it. So it's -I square root of 13. -64. So what's this one going to be? So it's -I square root of 64. What's the square root of 64? Square root of 64 is 8. So your final answer is negative 8i. Would you do that? They both mean the same thing. X3, 3x mean the same thing. It's always customary to put the coefficient in front of any letter or equation or anything. Put the coefficient in front. Square root of negative 48. Take this one as far as you can. This negative inside here becomes a what? It becomes an I. So we have I square root of 48. What can we do with 48? Well, let's break it down. What's 48 made up of? 2 times 24. 24 is made up of 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So 48 is 2 times 2 times 2 times 2 times 3. Because it's a square root, we look for a pair of numbers. Here's a pair of numbers, so it can go out in front. Here's a pair of numbers, it can go out in front. And there's that I. So we have a 3 left inside there. So the answer would be 2 times 2 is 4. I square root of 3. That's how you simplify as far as you can. Remember, a square root means you need 2 of a kind. A cube root means you need 3 of a kind. A fifth root, you need 5 of a kind. So far, so good? Now we have the algebra of complex numbers. Remember what algebra meant? Add, subtract, multiply, divide. The add, subtract part is pretty straightforward. Basically, it's combine like terms. So given an equation like this, can we do anything inside the parentheses? No. So do we need the first parenthesis? Is there a coefficient out there? No. So I can just drop the parenthesis. Plus, same with the second one. There's no coefficient, so I can just drop the second parenthesis. Now I combine like terms. 8 plus 3 is 11. Positive 6i, positive 3i, they're both positive. 6 plus 3 is 9i. It's the same as if it was x's. Look at blimp. What was your question? Yes, there was a misprint. Misprint by the publisher. 4 plus 5i minus 6 minus 3i. We can't do anything inside the parentheses. So do we need the first parentheses? No, we just drop it. But the second parenthesis has a negative in front of it. What do we do with that negative? We have to distribute it. So that negative times positive is a negative 6. Negative times negative is a positive 3i. So combine like terms. We have 4 minus 6. The 6 is bigger. It's negative. 6 minus 4 is 2. 5i and 3i are both positives. 5 plus 3 is 8i. It's the same thing. What if we had 8 plus the square root of negative 36 plus 3 plus the square root of negative 4? If you had that, what would you do? Well, first I have to get those inside the parentheses. What is the square root of negative 36? The negative comes out as an I. What's the square root of 36? So it's 6i. And the second square root of negative 4 is, yes, it's a negative, so it's an I. Square root of 4 is 2. So you'd convert them into imaginaries and then add them together. All right, let's look at multiplication. Multiplication. The biggest mistake students do, because remember we had this policy of square roots. So if I have them separated, can I combine them? Wouldn't negative 2 times negative 5 be positive 10? No. Do not fall for that trick. When you have these are imaginary numbers. They don't follow the same rules as these. So we have to do first, we have to get rid of the imaginary part, the negative inside there. And this one is I radical 5. Now you can combine them. So we have I, what's I times I? I squared. Then we have radical 2 times radical 5. Now I can combine these two. Am I done? No. What is I squared? It's negative 1. Well, yes, I squared is I to the second. Very good. So the answer is negative radical 10. Remember, I is the square root of negative 1. So I squared is negative 1. So we have square root of negative 16 times the square root of negative 25. So what does the first one become? I square root of 16. And then I square root of 25. What's the square root of 16? So it's 4I. Square root of 25 is 5, so it's 5I. 4 times 5 is 20. I times I is I squared. So it's 20 times negative 1, which is negative 20. So basically, whenever you see an I squared, just drop it and change the sign of the number in front of it. That's all I squared really does, just change the sign of the number. One plus 2I, 1 plus 3I. Again, we have to multiply these. So take the first term, so 1 times 1 is 1. 1 times positive 3I is positive 3I. 2I times 1 is a positive 2I. Positive times positive. 2I times 3I is what? 6I squared. Very good. Combine like terms. We have like terms here. 3I plus 2I is 5I. Plus 6I squared. Remember, whenever you have an I squared, what do? Just drop it and change the sign of the number in front of it. Because I could have done 6 times negative 1 becomes negative 6. That's too much work. It's much easier for me to just drop the I squared and change the sign in front of it. 1 minus 6 is negative 5 plus 5I. And there's my answer. Last example for the day, because we're going to finish up tomorrow looking at division. 3 minus 7I squared means 3 minus 7I times 3 minus 7I. Three times 3 is 9. Positive times negative is negative. 3 times 7 is 21I. Negative times positive is negative. 7 times 3 is 21I. Negative times negative is positive. 7I, 7 times 7 is 49. I times I is I squared. Combine like terms. They're both negative. 21 is 42I. This I squared changes that sign. So it becomes minus 49. Nine minus 49 is negative 40. minus 42i. And there's your answer. Now, the thing we'll finish up tomorrow with this, we have two topics to discuss. Division of imaginary numbers. And what if I gave you that? How would you simplify it? Because remember, the rule is you cannot have an exponent on I. I cannot have an exponent. So I'm going to show you how to get rid of that exponent tomorrow.